So before we start, be sure to subscribe to my channel. So okay, so in this video, we are trying to prove this property of Fourier transform. And let me just remind you guys that this is our definition. So f of t times exponential minus j omega t dt. This is our definition of Fourier transform of this f. So basically, this table means that yeah, this is the Fourier transform. Okay, so first one is trivial. Okay, linearity thinks that af plus bg can be written as, you just think integral is linear. Okay. The second is time scaling. So for time scaling, we have this. Okay. So if a is larger than 0, then we can let t tilde. So t tilde now is basically this. Okay, so this is exponential minus j omega t tilde divided by a, d tilde divided by a, and the a is positive, so this is still this. So this is 1 over a f, right? Omega divided by a. Okay, so and if a is negative, then this will be negative infinity, positive infinity. So there will be a minus sign. So you will get this. Right, but be sure that since a is negative, right? So basically this is basically this. Okay, so we have proved this. Okay, the third one is called the time shift. Okay, so let me quickly do it. Okay, don't worry. This will be very easy. Okay, so time shift, right? So you have this f t minus large t dt. Then this is basically t tilde. So f t tilde exponential j omega t tilde plus t d t tilde. Right. So this is just right. You see. So this is your answer, but times this. Okay. So this is also trivial. Now we are proving the differentiation. So differentiation, we need to use the integration by part. So okay, so df dt, right? Suppose this is what we want to do, right? So we use the integration by part. This is f, right? Exponential j omega t minus f, and the j omega t minus j omega t to do a differentiation respect to t. So we have this, right? So this is infinity, infinity. This is also infinity, infinity. This is 0. The first term thinks that the Fourier transformation exists. So f is 0 when t goes to this. Okay. So this is j omega f of t j omega dt. So this is just j omega f of f omega. Okay. So we have proved this one. So what we have proved is f, right? df dt is just j omega f of omega, right? So f of d square f dt square is basically j omega f df dt. So it's basically j omega square f of omega. Okay, so by induction step, if you change these two to be k, then this will be k. Okay, so let me prove the integration. Okay, so for integration one, yeah, so one result we have proved, or basically if you don't know that, you can find my previous video, is if I define a step function to be this, right? So this is a step function. Basically, when t is larger than 0 is 1, right? So, and we have proved that the Fourier transformation of step function will be what? Will be 1 over j omega plus pi right, will be pi this. Okay. Yeah. So if you don't know that, you can go back to see my previous video. And we also need to use this convolution. So basically, we will we will assume this is correct and prove this, and finally we go back to prove this convolution. So this convolution is the most important one. Yeah, possibly that this is the only important things you need to prove. Okay, so now we suppose we know this, right? So this t to infinity f of t tau d tau can be changed into infinity f of t also f of tau d tau. Right. So basically, this integration can be written times u t minus tau. Okay. So if you see the convolution term, right? So basically, this is exactly the same as. So this is f. Convolution is step function, right? So t with respect to. So this is tau. Okay. So yeah, convolution. So this is t, right? So further transformation of this will become f of omega times this j omega plus pi delta omega. Okay. So the first term is here, and the second term, since omega is only, so basically this delta function is only non-zero at omega equal to 0. So this is, so the second term f of omega pi delta omega is exactly the same as pi delta omega f of 0. Okay. So we prove this. Okay. So now we can go back to see the convolution. I'll go back to see this multiplication. Okay, so this multiplication is basically a trivial one. We have proved this. Oh, this. Okay, so multiplication is very easy because f of omega is just sorry, exponential j omega t. Right, and you just respect to omega, right? So you just first do the k term. So each time you do a k term, that you pull out this jt, right? So jt to k f of t dt. So this is minus jk infinity tk f of t dt. Okay, so there's still this j omega factor. So this is minus jk, and okay, so this is f of t t k f of t, right? So this is basically just Fourier transformation of this. You get this. Let me see. So this one is basically this one divided by this one. I think one. Let me check. Okay. Let me see. So yes, this should be positive. Let me see. So it depends on your notation, right? But I think generally this should be minus. So I think there should be minus j to the power k, right? So basically I should change it into this, right? But or basically you should change it to this. Okay, yeah. So this should be this one. Okay. Okay. Now we go back to the convolution. I think in general for the transformation definition, this should be negative. So that's why this is negative. Okay, so suppose the reason is that suppose you do this, right? Then if you in this time shift, you change it to t tilde, then t will be t tilde plus tau t, right? So yeah, so there will be a negative here. So this should be 1 over j to k. Yeah. Okay, so now we go over to prove this convolution. Okay. I will make another video to prove this convolution. So now we do so this is tau g t minus tau d tau exponential minus j omega t dt, right? So this is Fourier transformation, and we combine all the parts have the t part, so we get the tau d tau. Okay, so maybe let me just write yes. We combine all the t into here. So dt. Okay, so this one. Okay, and this term is basically g of basically it's g omega. We already proved. Basically, it's the shift one, so it becomes this. Okay, then you can see this is tau, right? So there's no tau. This is tau, right? Tau. So you can this g omega can be pulled out, and you get this. This is tau j omega tau d tau, right? So this term is basically f of omega. Okay, so this is trivial. Okay, finally, this multiplication is basically the inverse, right? So you can do the inverse transformation of this, right? And then you do a similar trick, then you can get this. So basically, once you prove the convolution, then this is multiplication is straightforward. Just use the inverse. Just notice that the inverse Fourier transform of the original Fourier transform will be identity. So if the convolution has this property, then the inverse one will give you the multiplication, right? So basically, this is a large F times g omega, and this is small f times small g. Okay, that's it, and I will see you guys in other videos. Be sure to subscribe to my channel. Thanks.